Hi and welcome to my maths class. Now, when we were doing the first principle, we were doing the derivative specifically using the first principle. Now, why do we call it derivative or first principle? Remember, the first principle is the gradient. But this is a gradient of a curve. So when we're doing derivative of first principle, we are getting the gradient of a curve. Now you've done the long method. What we're going to do is we're going to do a short method. The rule for the short method is, if I've got a x to the power of n, if that is our f of x, which is maybe our equation, then the gradient or the derivative is going to be n times a x n minus 1. Now when you put it like this looks confusing and challenging, but if you do an example, then you see how easy it is. Let's take an example of a first principle that we've done before. So if you take, let's take 2x squared minus 3x plus 1. 2x squared. Okay, so we're going to use the equation 2x squared minus 3x plus 1. You've done first principle. Now following the rule, the n is the power. It's going to come in front and it's going to multiply with the constant. So 2 is the power. So we're going to move 2 in front. So we're going to get 2 times 2. And then we've got our base, which is x. And we're going to say the power minus 1. So our power was 2. So we're going to say 2 minus 1. Then we're going to do the exact same thing with minus 3. Now, what is the power by the x? 1. We're going to bring the power in front. So we got minus 3 times 1 because of the power x. And then we're going to have 1 minus 1. Now, what is interesting is that 1 is x to the power of 0. Because from your exponent rules, you know x to the power 0 is equal to 1. So if we put x to the power 0 and then we try and apply the rule, you are doing derivative with x. So you need an x to do the derivative. So if there's no x, we are putting it in. But by putting x to the power 0, we are not changing the question. Now look at the 0. As soon as the 0 comes in front, you're going to have 0 times anything is 0. So as soon as we move the 0 in front, we know, hey, we don't need to go on because it's 0. Now what have we done? What have we done? We have done the derivative. And we have to clearly show that, listen, I know I have the equation. I'm doing the derivative. I'm getting the gradient of it. So by showing that, how do we show that? We put f and then you put the little copy and you put x. Okay, so it is important how you're writing it. Now let's get our final answer. 2 times 2 is 4, x, 2 minus 1 is 1. Then we have minus 3 times 1 is 3, x, 1 minus 1 is x to the power 0. And we have our 0. That gives us a final answer of 4x minus 3. Because x to the power of 0 is 1, so we're saying 3 times 1 gives us 3. Now look at the answer that we have here, and of one where we had done the first principle. We had done the first principle and look at our answer in first principle. It's exactly the same. So we ended up with exactly the same answer. Now, it is not always so simple. There are a few specific rules that you have to remember when you are doing this form of derivative. Number 1, there must be no brackets. Number 2, no root signs. And number 3, no denominators as unknowns. Now, many of these rules are actually available in your exponent. You would notice no brackets is like your kitty cat or your FOIL method. No root sign is basically your inside over outside. Inside over outside. And no denominators is usually, when you bring your denominator up, then it becomes a negative power. And let us do examples. Right, if I told you, I want you to find the derivative of the following equation. Now you can't just go and do the derivative of 3x squared and then do the derivative of 4x, then do the derivative of 2x. That would immediately be incorrect. The rule says no brackets, which means that if you are given brackets, you have to get rid of the brackets. Now you can use kitty cat, you can use FOIL, you can use anything that you're comfortable with. So what do we have when we get rid of the brackets? Now look at how I am writing. We are still working with f of x because all I am doing is getting rid of the brackets, simplifying. So I've got 6x cubed minus 4x minus 8x squared plus 3x squared, which is equal to 6x cubed minus 5x squared minus 4x. But now you haven't yet done derivative. Now you're going to apply the rule ax to the power n, then the derivative is equal to nax n minus 1. So this is the rule that we are going to apply. So we're starting with this, bringing it in front. We've got 3 times 6, and then we've got x 3 minus 1. Then we're going to do the same with the 2. So we've got minus 5 times 2 x 2 minus 1. Then here the power is 1, so we bring it in front. So we've got minus 1 times 4 x 1 minus 1. Now we've done derivative. As soon as we applied this rule, we've done derivative. Now remember, the examiners are finicky about their writing. You don't write this, they're going to penalize you. So you have to say, I'm making a change, I'm doing derivative, I'm no more on my first equation. Also, you can't go and do derivative of this one and then not derivative of this one. So in other words, if you were to write something like this, 18x squared. Right, so what you've done is, you've done derivative of the first one, but you haven't done derivative of the second one and the third one. You just carried it down. Now you decide, okay, I'm done with 18x squared. Now I'm going to do this one. But I still never do this one. So you've done derivative of 2, but you never do of that one. Then you go and you say, okay, 18x squared minus 10x minus 4. This is not acceptable. You cannot do derivative part by part. You have to do the derivative of each and every term on one line. So if you are maybe sorting out your brackets or sorting out your roots, if you are done with one term, but maybe you're not done with the other term, you wait and you try and do it together. Otherwise, you will be penalized. Now let's go to our answer. What we did was we brought them all in front. We did it for each one, and now we give our final answer. 6 times 3 is 18, x to the power 2. 3 minus 1 gives me 2. Minus 5 times 2 is 10, x 2 minus 1 is 1. Minus 1 times 4 is 4, and x to the power 0. Now x to the power 0 can be written as minus 4. So our final answer is 18x squared minus 10x minus 4. This is derivative. So you must look at the beginning and the end. Can you see how different they're written? Right, let us do another example. If I gave you x over 5 and I told you, get me the derivative of x over 5. Now notice, the rule was no denominators that are unknowns. 5 is very known. You know 5. So in this case, you can simply do derivative. There's a 1 there, so we're bringing our 1 in front. So we got 1, x, 1 minus 1, all over 5. 1 minus 1 gives me 0. So I've got 1 over 5. But look again, the copy. Let's try another one. If I give you f of x is equal to 7x cubed over 2. Now again, my unknown is on top, not at the bottom. So you simply apply the rule, bring the 3 in front. So it would be 3 times 7, x, 3 minus 1, all over 2. So we have 21x squared all over 2. This is now f derivative x, f derivative x. Right. Now, every time I did derivative, the denominator was a known number. Something that I know, I can see. No unknown. No x. Let us do fractions that have unknowns at the bottom. When we do fractions with unknowns at the bottom, it's going to split two ways. Number one, you're going to see you're going to factorize, and then you're going to cancel, and then you would do derivative. Or you will separate, and then you would use your exponent rules to get non-fractions, or let's say non-unknowns at the bottom, and then you do derivative. Now how can you tell between these two? How do you realize, hey, when do I use this rule and when do I use this rule? Now there isn't a hard and fast rule, but the norm is usually you're going to always try to factorize. This is your first option, and this is usually your second option. But the major giveaway is you must look at the denominators. When the denominators tend to be two terms or more, when the denominators tend to be two terms or more, then it tends to go towards factorizing. But when the denominator is usually one term, then you see it tends to go towards separation. Now let's do an example. Now notice the denominator is two terms. You are not allowed to do derivative of the top and then derivative of the bottom and say, okay, here's my answer. You can factorize the top. What does the top become? It becomes x plus 6 into x minus 1 all over x plus 6. But remember, this is still f of x. Now this cancels out, so my f of x is now x minus 1. I haven't yet done derivative. You have to reach a point where it's in its simplest form, then only can you say, okay, now I'm doing derivative. Now what am I doing? This comes in front, so we got 1x, 1 minus 1, minus 0. Why 0? Because this has an x to the power 0 to it. As soon as I bring it in front, it's 0. So my final answer is 1. Let's try another one. If I give you f of x is equal to x cubed plus 1. These you know how to factorize already because you've done it under factor and remainder theorem and factorizing of 3Ds. So if you're not familiar with how to factorize this, go to factorizing 3D degree equations so you understand how to do this all over x plus 1. Now we're going to factorize. So if I factorize it, I have x plus 1 into x squared minus x plus 1. Now the x plus 1 can cancel. So I have f of x is equal to x squared minus x plus 1. You haven't done derivative. Now we start with derivative. We take it in front. So I've got 2x, 2 minus 1, minus, I'm bringing it in front, I've got 1x, 1 minus 1, and then this is a 0, x to the power 0, so I've got plus 0. Your final derivative is 2x minus 1. Okay, now let us do a fraction where you actually can't factorize. So if I've got x cubed minus 9x squared plus 11x minus 5 all over x squared. I can clearly see I can't take out a factor because minus 5 doesn't have an x. So what do we do? Now we do a separation. We're going to say x cubed over x squared minus 9x squared over x squared plus 11x over x squared minus 5 over x squared. So what is happening is that the denominator is going to every term on top. What do we do now? Now it's your exponent laws. We know that here I can cancel, so I have x left. Minus this entire x squared can cancel out, I have 9 left. Now if I take this x to the power 2 on top, knowing your exponent laws, if I got xn over x b, I'm going to have x n minus b. If you are not familiar with your exponent laws, you need to go to your grade 10 and grade 11 work. So what do we have now? We have plus 11 x to the power of 1 minus 2. Now why are we minusing 2? Because I'm taking this on top. Then we have minus 5 x to the power minus 2. We are still on f of x. We haven't started derivative. And you don't start doing derivative of the first two terms and not the last two. You only start derivative when the entire thing is sorted out, then you start derivative. So we're still busy sorting out. We have x minus 9 plus 11x to the power of minus 1, because 1 minus 2 is minus 1, minus 5 x to the power of minus 2. Now I can start my derivative because every term is ready. Now we bring this 1 over. Remember the rule, x to the power of n is going to equal to nx n minus 1. N times x to the power of n minus 1. This rule is going to always help you. It's the short method. It's the way to double check your work. So you must understand it. Without this, your entire calculus is lost. So we're going to bring it in front. We've got 1x to the power 1 minus 1 minus. Now what is this? We know this is x to the power 0. So immediately as soon as I take it in front, it's a 0. Plus, we bring this over. So we've got minus 1 times 11 x to the power of minus 1 minus 1. Can you see? The rule says add a negative 1. So we still have to add a negative 1. Then we've got minus 2 times minus 5 x to the power of minus 2 minus 1. What you notice is the x's are always decreasing by 1. So our final answer is 1, because x to the power of 0 is equal to 1. Then we have a 0, so we don't need to write that in. And we have minus 1 times 11 gives me negative 11, x to the power of negative 2. Then we have negative and negative is positive. 5 times 2 is 10, x to the power of negative 3, because negative 2, negative 1 is negative 3. If you want to write it neater, okay, then we have 1 minus 11 over x squared. Now why am I saying x squared? Because I am now bringing this down. Plus 10 over x cubed, giving us our final answer. Most of the times, if you leave your answer as this, you would be marked correctly. Okay, they are seeing if you know derivative and they are checking. So if we have very strict markers, then they're going to look for positive exponential. Or if they say things like leave your answer in a positive exponent form, then you have to convert it. But if they don't say that, it would be safe to just write that as your answer. Now the next style is your roots. Now if you are given a root sign, let's do an easy one first, so you can understand before we do a bit complex examples. X to the power 3 square rooted. Now the value outside is 2. And you know to change a surd, we got x inside over outside. If you are not familiar with this, then remember you need to go back to your grade 11 surds and your grade 11 exponents before you can continue with this work. Now, once it's changed to a non-root, then we are going to do derivative, which means bring the 3 over 2 in front, x 3 over 2 minus 1, giving us 3 over 2 x to the power of 3 over 2 minus 1 is a half. Now you can leave your answer in that form, but if you want to change it, the 3 over 2 is outside, the root, the x is your base, that's inside, inside over outside. So the top is inside, the The bottom is outside, but your whole number is outside. Let us try a more complex example. You know we are not allowed to have the root. So let's start with the first thing. 5 over 4 times x inside over outside. But now we have the problem where it says you are not allowed to have your unknown as the denominator. So what do? We now bring this on top. So we have 5 over 4. Now notice I didn't move the 4. I'm only moving the unknown. So when I bring it on top, it becomes x to the power of negative 5 over 3. I'm still busy with f of x. I haven't yet started doing the derivative. I didn't start bringing my power in front. Now let's bring our power in front. Now I'm going to bring the negative 5 in front. So we've got f of x, but now I can put my little copy because I know I'm doing derivative. I'm bringing my power in front. So I've got negative 5 over 3 times my 5. And then we have x minus 5 over 3 minus 1 all over 4. Can you see the rule is the same? But I'm only bothered with the top now. When we're trying to get the answer, all the constants, you can press it in the calculator. So if you press minus 5 over 3 times 5 and then you divide it by 4, you'll get 25, and our power is x minus 5 over 3 minus 1 is minus 8 over 3. Okay, so the constants we put in the calculator, we got an answer of minus 25 over 12. Then we have x minus 8 over 3. Now how did I get the 8 over 3? I said minus 5 over 3 minus 1. Now again you can use your calculator. Alright, now this would be an acceptable final answer. But if you don't want that, if they want a positive exponent, but remember these are not questions that are usually asked. Usually at that point they would expect you to stop. But if you want to go on, we got minus 25 over 12. That is the constant. This is a negative power, so I'm bringing it at the bottom. So it becomes x 8 over 3. Now look, I didn't swap the 8 over 3. It's still 8 over 3, but it is positive. Then I still got my minus 25 over 12, but the root now comes because I've got an inside and I've got an outside. So if you do want to continue after this, which is an acceptable answer, then you must know, bring your exponents down and then change it to a root with the inside over outside rule. Thank you for watching.